Welcome back. Up until now, I've been blabbering on about what machine learning is. And I hope you have a bit of an idea of why we have it and why it's useful. But at the end of the day, the only reason that we care about machine learning is that we're able to use machines to predict results based on incoming data. That's it. Now, this idea of machine learning, and don't worry, I know we keep talking about theory, but I promise we're going to get some coding exercises first. But I do want to talk quickly about some of the machine learning categories that you often see. And keep in mind what I said. That is, machine learning is simply about predicting results based on incoming data. And all these subcategories simply do that. For example, we have the idea of a supervised learning, which is a subset of machine learning. In this supervised learning, the data that we received already has categories. Think of it as a CSV files with rows and columns labeled. We have labeled data and a test data that is labeled so we know if our function is right or wrong. So in a supervised learning scenario, we can do things like classification to decide, is this an apple or is this a pear? Machine learning model simply draws a line to decide, hey, this is an apple and this is a pear. Or we might do something called regression instead of classification, based on inputs. For example, predicting stock prices. Another way that we might use supervised learning is, for example, to hire engineers based on inputs, based on years of experience, based on maybe age, maybe where they live, what type of computers they have. All these sorts of inputs that are labeled can be used in a supervised learning system to decide, should I hire this engineer or should I not? Now, sometimes we have data that doesn't have labels. And this is called unsupervised learning. Again, think of it as a CSV file without perhaps the column names labeled. Sometimes with things like clustering, we need to create these groups, or at least the machine to create these groups. For example, we give it a bunch of data points and then the machine decides, oh, this is a group, this is a group, and this is a group. Or we can have something like association rule learning, where we associate different things to predict what a customer perhaps might buy in the future. When groups don't exist, we call it unsupervised learning. We can't tell the machine that they are right or wrong like we can when we do apples versus pears, since there are no true categories, but we let the machines just create these categories for us. Finally, we have this idea of reinforcement learning. And reinforcement learning is really interesting because it's all about teaching machines through trial and error, through rewards and punishment. So the program simply learns a game by playing it millions of times until, well, it gets the highest score. It doesn't know what it's doing at first, but then it tries to maximize the score and eventually figures out that, hey, maybe I should try and move where the ball is coming. So this is seen for skill acquisition or real-time learning. And you see it a lot in machine learning programs that play, for example, video games. But the idea here is that machine learning has different categories and different ways to accomplish its goal. And topics like neural networks, decision trees, support vector machines, k-nearest neighbor are simply algorithms that are used with these subfields in order to come to these predictions. But remember the key thing. All of these, what they're doing is trying to learn from the data that it receives and predict something. I'll see you in the next one. Bye-bye. One thing that I really like doing in my courses is to actually understand the why of everything. Everything that we learn, there should be a reason we're learning it, right? And you might be asking yourself, why do we even care about machine learning? How is that useful and how do we get here? Well, if you think about a business, because most technology evolves from business needs, we have the advent of computers and the ability for businesses to use computers to do things really, really fast and efficiently so that they gain an edge. And then we got spreadsheets. Spreadsheets like Excel files and CSV files were amazing because we can store data that businesses generate, such as maybe customer data, into an Excel file. And then people got really, really good at analyzing these CSV files, these spreadsheets, to make business decisions. Maybe forecasting that December sales are going to be high because, well, the past 2 years we've had really high December sales because of Christmas. And then as companies got more and more data, we started getting this idea of relational databases. Spreadsheets were great, CSV files were great, but we started getting more and more information and data, and we needed a better way to organize things, to understand things from our data. That's when we got things like MySQL, which allowed us, instead of using spreadsheets, to use a language called SQL to read information from our database, write information to our database, but similar to spreadsheets, use the data that we gathered from the business to make business decisions so that our business becomes even more profitable. And then in 2000s, we had this fancy term of big data. We had big companies like Facebook, Amazon, Twitter, Google that started accumulating more and more data. An insane amount of data that you simply couldn't contain in a spreadsheet. User actions, user likes, user purchasing histories. This idea of big data meant that we had so much data. These companies had so much data. And sometimes, unlike relational databases, which had to be a structured form of data, sometimes we got really messy, unstructured data. And that's when we started getting this idea of NoSQL, where things like MongoDB came into existence, where you can store unstructured data and hopefully make business decisions out of that. Maybe if you were Amazon, you can use customers' purchasing history to recommend different products. And ever since then, this idea of data, getting more and more data, has turned us into using machine learning. Because at some point, we have so much data that as humans, we can't just look like we did at spreadsheets and look at columns and rows and make business decisions. I mean, we still could, but then we'd be wasting all this data that we've been getting over the years. So companies like Facebook and Google that collect massive amounts of data every single day are turning to things like machine learning, so that instead of humans looking at the data and trying to figure things out, we give this data to machines so that they're better able, even better than humans, to make business decisions. And this idea of machine learning really came to be because of this growth in data that we received from businesses, as well as the improvements in CPUs, GPUs, that is graphical processing units, and computer advancements. So using the massive amounts of data and massive improvements in computation, we can use these machines to give them this big data and make decision for us, just like we used to with spreadsheets. Now, this is a simplified version of how we got here, but I hope it gives you a reason as to why businesses like this idea of machine learning. Now, in this course, we're going to be using this framework. And don't worry, don't get intimidated. You're going to get really familiar with this framework because, well, we're going to talk about it a lot. But looking at this, just a brief overview, what do you think the hardest part is? Can you guess? It's this first part right here, grabbing the data. You see, amount of data is doubling every 2 years in our world. With the internet, all the mobile phones and connected devices, we're creating more and more data. But this data doesn't mean anything unless we understand it. Yes, we are producing data, but a lot of this data that we generate is unused. And that's what data science is. How can we use this massive quantity of data that is completely useless right now to something that is useful? And not all data is made equal, right? Some are noisy, some are messy. Where do we grab this data from? How do we find it? How do we clean it so we can actually learn from it? We need to understand what data is and then apply machine learning to it. And the industry is now evolving into these people that we want to be, data scientists. That is, people that can turn data from useless to useful. Here are the big words that are taking the industry by storm: machine learning. Now, throughout the course, we're going to explore this topic as well as data science and how it all fits into the tech space. But first things first, you need to be able to explain this topic to your coworkers and not look like you don't know what you're talking about. So let's start with this. You see, machines, or computers in this case, are really, really good at certain things, right? Machines can perform tasks really, really fast. And we can control these machines and get them to do tasks for us, which is what programming is. We program computers. We give them instructions to do tasks, and they do it for us. You see, computers came into this world because it allowed humans to do certain tasks really fast that may have required hundreds of workers before. I mean, computers used to actually mean people who do tasks that compute. They computed things. So for example, let's say I wanted to find out how to get to Daniel's house using Google Maps. Well, one option is I could pull out a map and with a ruler measure each of the routes that I could take to Daniel's house. And then do some math, do some addition, and find the shortest path. Or I could ask a computer to do this. Imagine we had 10 different routes. Instead of me measuring each route one by one, I could simply program and ask a computer, hey, can you tell me how to get to Daniel's house? And through programming, we tell the computer, can you calculate really quickly these 10 routes and find the shortest one? That's what programming is. Instead of me taking 10 minutes to figure out how to get to Daniel's house and the fastest route, I just click a button and the computer tells me what to do. Obviously, we have to program it and give it instructions, but once we give it a set of instructions, it, just like that, finds the solution for us. It computes solutions. And you know why computers became so popular? Because computers saved companies lots of money. Instead of hiring lots of workers, well, let's just buy a computer that does the task of 100 workers, and there you go. We saved a lot of money, and computers don't complain. They'll work 24/7 for you. Now, these machines or computers are really good at things that we can describe, right? That we can write in code, if-else blocks to do something. By the way, if you're new to programming, don't worry. We're actually going to start you off from scratch as well with Python. So don't worry, this part is just theoretical. So for example, let's say we talk about routes. I can say to the computer, hey, if route 1 is shorter than route 2, and if route 1 is shorter than route 3, and if route 1 is shorter than route 4, and also route 5, well, then pick route 1 as the best option. I can describe that through programming to computers. And computers are really good at working on tasks that have these defined rules, all the way up to a game of chess. When you play a game of chess against a computer, we could technically have these if, else, if, then blocks, lots of them, to see how to move each piece and what the pros and cons are. And because computers are fast, we can just do a ton of these calculations. But then there's a problem. What if instead of just trying to get to Daniel's house, we have to ask, is this person angry? Let's say somebody left a review on Amazon. or we're building a product that detects human emotion. How can I describe to a computer what angry means? Can you do that if an if-else block? What about this? What is a cat? How do we tell a computer what a cat is? Let's say I ask you to program a computer to detect if this picture is a cat or not. Can you program that? I mean, sure, you can technically say, yes, this cat has fur. This cat has whiskers. This cat meows. But then the computer comes back to you and asks, what is a meow? Or what are whiskers? What is hair? You see, the harder things become to describe, the harder it is for us to tell machines what to do. So we hire humans to do these things that are harder for us. So we let machines take care of the easier part, which is, things that we can describe. And the harder things that are hard to just give instructions to, well, we just let humans do it. Like being a salesperson or being an artist. Computers aren't good, so we hire humans. But then there's this new idea of machine learning. And you've definitely heard of it because it is a big buzzword right now in our industry. Because machine learning has a lot of applications. We could have self-driving cars, robots, vision processing, language processing, recommendation engines, translation services, stock price predictions. There's so many applications. And this is all because of machine learning. You see, things that computers couldn't do before and only humans can now be done by computers with machine learning. Well, kind of. Sometimes it gets it right, sometimes it doesn't. And we'll get to that. But the idea is this. The goal of machine learning is to make machines act more and more like humans. Because the smarter they get, the more they help us humans accomplish our goals. Now, in this section, we're going to go over some theory to get us familiar with this topic, to understand this topic a little bit more. But don't get worried. Don't get intimidated. We're going to try and simplify things and have fun along the way. And in later sections, we're actually going to code, build our own machine learning models, and do that exciting stuff. But we have to learn the foundations first. So let's take a break, and I'll see you in the next video. Bye-bye. So what is machine learning? Now that you've gotten inputs from both myself and Daniel, you should feel comfortable answering your coworkers, right? As a final challenge, I want you to pause this video and go to our Discord server, into our machine learning and data science channels, and just in brief 5 sentences or less, explain what is machine learning. If you can explain it in less than 5 sentences, good, then you've comprehended this first section. We're just getting started, but that's all we want to do for now. So what is machine learning? Well, we learned that computers are really good at processing large amounts of data that we're creating more and more of. Machine learning lets computers make decisions about data. It lets computers learn from data and they make predictions and decisions. What product does YouTube recommend? Does this person have a heart disease? Is this email spam? All use machine learning. So we essentially let computers decide for us. Although computers only understand numbers, at the end of the day only ones and zeros, using machine learning, we found ways to essentially let computers decide for us and answer hard questions that in the past only humans could answer. But machine learning at the end of the day is just a general term for when computers learn from data. It allows computers to do tasks that in the past required humans and make our lives, hopefully, easier. I'll see you in the next section. Bye-bye. Welcome back. It's time to do a fun exercise, even though we've barely scratched the surface and we just started the course. We're going to build a YouTube recommendation engine, but our own. Okay, so how can we do that? Well, I have here a great website, a machine learning playground. And what we have here is a blank box. I want you to open it up. I'll link to this resource and try this out yourself as well. Now, let's imagine that on the y-axis here, it represents the length of the video. That is the length of the YouTube video. Now in here, we have the length, and across the x-axis, that is right here, let's say that this represents the likes on the video. So from less likes to more likes, from shorter length courses to longer length. And we look at our user's data. Let's say we have a user Bob, and Bob likes to watch videos in this area. And he has clicked like on these types of videos. And with the purple, if I click on purple here, he has clicked dislikes on all these videos. Okay, let's think about this. So he has disliked a lot of videos that have lower likes from others and videos that seem to be shorter in length. And he has liked a lot of videos that have really good likes but tend to be longer in length. So if I click train here, and we can ignore all these little buttons and the parameters, let's just click train. This is what a machine learning model does. It tries to predict based on data. So we've given it this information of what Bob likes and what Bob dislikes, and we trained it to figure out the pattern so that when we now recommend a video to Bob, we know which ones we should recommend and which ones we shouldn't. For example, let's say a new video is uploaded to YouTube. And this video, well, right off the bat gets a lot of likes. And it gets a lot of likes and it's super long. So it's right here. Should we recommend this video to Bob? Yes or no? Well, yes, right? Because from past data, we've learned that we should recommend any videos that fall into this orange category. But let's say there's some new data point. Let's say Bob starts watching new videos and then we see that, oh yeah, Bob also likes these videos, these videos. What happens? Well, let's train our model again. And this is the new model that we created. So now, our machine learning model is telling us, hey, recommend any videos to Bob that fall in this orange category. You see, it's a little bit more complicated now. So with each data point, we're able to learn about what Bob's preferences are and then train the model to decide if we should recommend and add the video to Bob's YouTube feed or we should not recommend it because they're probably not going to watch it. What we've just witnessed here is us building our own recommendation engine. Now, obviously, this is a simplified version, but at the end of the day, this is exactly what we want to do. We give inputs to machines, and the machine decides and draws a line to figure out what we should predict for a future input. That is, a new video comes up. Should we recommend it to Bob or should we not? Congratulations. You just created your own YouTube recommendation engine. Kind of. Now, I want you to play around with this, play around with the parameters. Let's say we add 5 here and we train, we do decision tree and click train. Now, you don't need to know anything about these, just to play around and see what happens. And I'll see you in the next video. Welcome back. It's time to have a little bit of fun because you've just been listening to me talking for a bit and we want to get our hands dirty and try this machine learning ourselves. But even though we don't know much about it yet, we can actually play with it. For example, there's a great website here by Google called Teachable Machine. And as you can see, what it does is, well, it helps you do some machine learning activities. So if I click on Get Started here, and by the way, by the time you watch the video, maybe they've changed the layout of this website. It doesn't really matter because this is more for you to kind of understand how things work underneath the hood and even play with this yourself. So let's create an image project. And for now, all we're going to do is say, hey, I want to decide or create a machine learning model that detects faces or cats. So let's just say this is going to be faces and this is going to be cats. and we have to give it some image samples so that the machine can learn, right? So in here on my desktop, I've actually saved a couple of photos. I found a nice little cute cat picture online. So let's upload the cat picture. So we'll upload the cat picture here. You can see that we're only uploading one. And here I will upload the faces picture. We'll upload the baby's picture here. Awesome. So we have faces and cats, and then we train our model. We essentially tell the computer, hey, this is an example of what a face looks like, and this is an example of what a cat looks like. So just learn, please. So you can see over here, it's learning. And there you go. It now has created a model. Now in here, I can use my webcam, or I can just upload a file. So let's just upload a snorkel picture that I have of myself, and I click open. There you go. This model that we trained thinks that this has a 49% chance. Let's make this a little bit bigger. This has a 49% chance that this image is a face and a 51% chance that I'm a cat. What's going on here? What if we give it a better picture? I mean, this is a tough picture, right? It's a little bit fuzzy. I have my snorkeling mask on. Maybe it's a tough picture for this model to predict. So I'm going to upload a different file. Let's say this exact same face that I use in the image. If I click open, oh boy, that's even worse. It thinks I'm 57% cat, and it's 43% certain that this is a face. What's happening here? Well, what you've just witnessed is how machine learning works. We provide the computer some data. In this case, I provided one image of myself and Daniel's face and one picture of a cat. Based on those two inputs and data, I say, hey, computer, learn, try to understand this picture, and try to understand this picture. And next time I give you any images based on this data, predict for me or tell me how much confidence you have that either it's a cat or a face. And that's pretty much machine learning. It doesn't have to be just images. It just needs to be some sort of data. We train the computer and we create a model that can predict for us based on that data. Now, we see here that it's really, really bad. I mean, this is definitely not a cat, right? So why is it bad? Well, think about this for a second. Try to answer it on your own. Ready for the answer? Well, number one is that we've only given it one image each. For a computer to really learn and to understand what a face is, what a cat is, it needs hundreds, thousands, if not millions of images of cats to detect patterns, to figure out, hey, this is what a cat is. Hey, this is what a face is. Right now, I've only given it one sample each. So this model is not very smart. Just like a human, right? To learn something in school, you have to repeat it. You have to see it over and over. And then also with the preview, sometimes I give it a really clear image of a face, or sometimes I give it the snorkeling picture that's really fuzzy. So that also affects the output. But at the end of the day, machine learning is just that. We give it some input, and then we tell the machine to learn based on those inputs and give us an output next time we give it a new input. Now, I want you to take a break here. I'm going to link to this resource so that you can actually play with this yourself and see if you can improve this model. You can even have your webcam on. So instead of a file, you have your webcam, just like in the examples that they provide. So if I go to Teachable Machine, you can see here different projects that you can build just by clicking without programming anything. You can even export your model once you're done so that you can use it in your own projects. Again, if this is confusing, don't worry. We're actually going to go step by step, and instead of just doing something visually, we're actually going to code and learn how machine learning and data scientists work. But this is a great way for you to just understand on high level how machine learning works. So go off and play with this website, and I'll see you in the next video. Bye-bye. Okay, so we have an idea of what machine learning is, kind of. But then there's other things, right? Like AI, artificial intelligence, data science, deep learning, neural networks. What are all those things? Now, let's look at machine learning and how it fits into some of the other words you may have heard. Now, you have to keep this diagram in mind. You see, it all starts with AI, or artificial intelligence, which simply means a human intelligence exhibited by machines. An AI is a machine that acts like a human. And currently in our industry, we have something called narrow AI. That is, machines can be just as good or even better than humans at specific tasks. For example, detecting heart disease from images, or at a game of Go or chess or StarCraft and other video games. But each AI is only good at one task. Narrow AI that we currently have simply means those machines can only do one thing really well. They can't be like humans and have multiple abilities. That's called general AI. And it's something that we're very, very far away from now. Machine learning is a subset of AI. And machine learning is an approach to try and achieve artificial intelligence through systems that can find patterns in a set of data. And actually, Stanford University describes machine learning as the science of getting computers to act without being explicitly programmed. That is, getting machines to do things without us specifically saying, do this, then do that, if then, if this then that. And don't worry, we'll explain that more throughout this section. Now, you may have also heard of deep learning. And deep learning, or deep neural networks, is just one of the techniques for implementing machine learning. For now, you can just think of it as a type of algorithm. But then we have this other thing that we've heard of, right? That's also very popular. That is data science. And often, the role of a data science and machine learning expert are quite overlapping. And most job descriptions actually don't even have a clear distinction between what is a machine learning expert and a data science expert. The field of data science simply means analyzing data, looking at data, and then doing something with it, usually some sort of a business goal. So when we talk about machine learning, there's a lot of overlap with data science, and that's why this course is called Machine Learning and Data Science. If you are a data scientist, you need to know machine learning. If you are a machine learning expert, you need to know data science. So throughout the next couple of videos, we're going to be talking about both of these topics because both of them relate and overlap. And you can't do one without the other because you need to be able to understand data and work with data to do any of these things. That's why when we talk about careers, often things like machine learning, data scientist, data analyst, they're all similar because they all work with data. And from that data, they want to derive some sort of action for their business, for the company, or for their users. Now, in this course, we're really focusing on the application side of things. That is, the day-to-day use of machine learning and data science. We won't focus on theoretical academic research, which means you won't need a PhD or be a super smart mathematician or statistician to do this course. The focus is on using machine learning and data science to be productive and to get job ready, because that's what companies want right now. Now, when Daniel starts introducing data science and machine learning, he'll combine these two into one and move this machine learning circle inside of data science. That's because the goal of the course is to encompass this entire data science field and teach the machine learning aspects within data science. By the way, you might be wondering, hey, what about this whole data engineering thing that I've heard about? That's another term, isn't it? What about that? Talk about that, Andre. Well, you know what? We have a whole section on it later on in the course, so for now, pretend like it doesn't exist. We'll get to it. I promise. So now that we have an idea of what these big words are, let's have some fun in the next video.
Let's start from the top with what is machine learning. Well, machine learning is broad. It contains many different aspects, and you'll see many different definitions of it online. But for the sake of this course, we're going to keep it practical. In a single sentence, machine learning is using an algorithm or computer program to learn about different patterns in data, and then taking that algorithm and what it's learned to make predictions about the future using similar data. Machine learning algorithms are also called models, and we'll use the term interchangeably throughout the course. How machine learning algorithms differ from normal algorithms and computer programs is the learning aspect. Let's use an example where a normal algorithm could be a set of instructions, such as how to turn a pile of raw ingredients into your favorite honey mustard chicken dish. The set of instructions might start out by saying, first, cut up the vegetables, then season the chicken, then preheat the oven, etc. And if you follow these steps correctly, you'll end up with your favorite honey mustard chicken dish. Oh, that's making me hungry, actually. We'll get back to it. What's important to note here is you started with an input, your set of ingredients, and a set of instructions on what to do to get to your favorite dish. What happens with a machine learning algorithm is instead of starting with an input and a set of instructions, you start with an input and an ideal output. In our case, the ingredients is the input and the output is our favorite chicken dish. And what a machine learning algorithm does is it looks at the input, the raw ingredients, and then it looks at the output, the favorite chicken dish, and it tries to figure out the set of instructions in between these two. Now think about this. If you tried to do this, on your first try, you might not get great results. You might put in too much spice and the dishes come out far too hot. On your second try, you get a little closer. But when it comes to machine learning, sometimes there may be hundreds, thousands, or tens of thousands of these combinations of inputs and outputs. If you looked at the set of ingredients and ideal outputs, your favorite chicken dish, 100+ times, you'd probably get pretty good or pretty close to figuring out what the set of instructions are to make that dish. Now, we're missing out a few steps here, but this is what machine models do in a nutshell. They find patterns collected in data so we can use those patterns for future problems. In our chicken dish example, a machine learning algorithm might find a way to create a delicious chicken dish given the right ingredients. That way, instead of thinking about what dish we could make with what's in the fridge, the machine learning algorithm tells us. You might be thinking, hey, I've heard about data analysis and data science as well. How are all these different? Great question. Data analysis is looking at a set of data and gaining an understanding of it by comparing different examples, different features and making visualizations like graphs. For our example, this might be looking at different samples of ingredients and comparing them. What do all the ingredients have in common? Are some of them missing something? Which have the most of a certain type of thing? Data science is running experiments on a set of data with the hopes of finding actionable insights within it. One of these experiments may be to build a machine learning model. This model might look at 10,000 different sets of ingredients and 10,000 different chicken dishes. Then tell us, based on a set of new ingredients that we have, which chicken dish these ingredients are most likely to make. You can consider data analysis and machine learning as a part of data science. Don't worry if all of this seems unclear for now. By the end of this course, you'll have had plenty of hands-on experience with all of these. Before the next lesson, take a minute to think about an example of a set of instructions you followed before. Do you think if you were shown the inputs and the end goal of something enough times, you could work backwards and figure out the instructions it took to get there?